All right, y'all. Today we're going to learn about ratios. That is our big goal today. We're going to talk about ratios, an introduction to ratios. We have some learning goals. We distinguish between additive and multiplicative relationships between two quantities. We understand the concept of a ratio. We write ratios in different forms and use ratio language to represent relationships between two quantities. We distinguish between part to whole ratios. We also are going to understand that percents are also part to whole ratios between a quantity of 100. So throughout this video, if you need to pause and be able to copy down and highlight information, please do so. I'll also give inclinations about when to pause and to make sure you have your information copied. All right, let's begin, students. Let's go. So let's start with page. Let's make sure we're on the correct page. We're on page 169. So that is the page you should be on. We have some key terms here. Two major ones we're going to talk about prior to ratios to get all deep and nit and gritty into those is additive reasoning and multiplicative reasoning. Notice we will write some terminology with ratios and percents as we go throughout. So let's do with the first problem here. Laquan put $15 in savings this week. This was 3 more than the amount he put in savings last week. Notice those some key terms I need to highlight. Laquan, $15 in his savings account. 3 more. We know what the word more means in math. How much did Laquan put in savings last week? So Laquan puts $15 in savings this week. This was 3 more. More means add 3. We're familiar with that. More means to add. So what was the mystery amount, I wonder? That's 12. 12 plus 3 is 15. So we had to have $12 in his account initially. Joanne bought 3 times. So we know what that key word means. 3 times as many books as Mitchell or Michelle. I don't know which one that is. I might mess that name up, y'all. At the book fair. If Michelle bought 5 books, how many books did Joanne buy? So Michelle bought 5 books. So we know Michelle bought, excuse my horrible handwriting today. It's not working well on this pen. 5 books. Joanne buys 3 times as many as Michelle. So that's 3 times 5. So Joanne had to buy 15 books. All right. You should take a minute to pause the video to copy this information down, my highlights and written explanation. So I'll give you a second to copy that down before I move on. All right, here we go. We are going to go to the next page, predict score. Now, this page we'll come back to in a little bit. We're going to get some examples written down first. So this is page 170. We will come back to page 170 shortly. We're going to move on quickly to page 171. So page 171 is what we're going to start with. So let's look up here. Okay. So in this one, we're looking at additive and multiplicative reasoning. That's what we're going to refer to, additive and multiplicative reasoning. So Rabania and Urin each predicted the final score of a basketball game between Crusaders and Blue Jays. So they're talking about 2 games and 2 competitors. So we have 2 key pieces of information. We're looking at Rabania and Urin's information. Those are the 2 we're looking at. So as we look at these 2, let's notice some information. Crusaders halftime score, we notice that's 30. We see Blue Jays halftime score is 20. We see Crusaders final score is 60. We see Blue Jays final score is 40. Let's look at some of Irwin's data. His Crusaders halftime score is 30. The Blue Jays were 20. The final score is 50. The Blue Jays were 40. So it's just some information we notice. And let's see what else. Okay, so Let's change some of this color so we see a little more distinction. I'll use red because I like red. So once again, we have Robania's scores, we have Erwin's data. Part A, describe the reasoning that Robania and Erwin used to make each statement. So let's look at their information here. I noticed the Crusaders' halftime score started with 30. The Crusaders' final score ended with 60. I noticed Blue Jays started with 20, and then it ended with 40. So if I look at this information, I notice how did 20 become 40 and how did 30 become 60? They multiplied by 2. Remember, these are predictions, but these are also the records that they kept for the scores, but this is their predictions. So 30 times 2 is 60, 20 times 2 is 40. This looks like a multiplicative reasoning. Remember, multiplicative has the word multiply. Multiplicative reasoning. So Robania is clearly thinking about the scores being doubled, multiplying. Let's look at Erwin's. How did 30 become 50? How did 20 become 40? Erwin was thinking about adding 20. 30 plus 20 is 50. 20 plus 20 is 40. So this is additive reasoning. So they have two different ways of approaching the answer. That's what they predict is going to happen. So in part A, it says, describe the reasoning that Robania and Erwin used to make each statement. We just described it. Robania is thinking multiplicative. And Erwin is using additive. Remember, these are predictions that they think is going to happen. It may not be true. Multiplicative means to multiply, additive means to add. Based on the two predictions, which team scored more points in the second half? Well, if we look at these, let's pull it up. For Romania, the final score was 60. Let me change colors. I like to use this cool blue. The score was 60 for the Crusaders and the Blue Jays was 40. For Erwin, the final score was 50 and the Blue Jays was 40. So clearly Robania, or Robena. I can't even pronounce her name, y'all. I ain't gonna lie to you. Robena, or Robania, is using, based on two predictions, which team scored more points second half? Robania. Robania Crusaders scored more points. All right. So now we're going to scroll back up. We just completed page 171. If you need to take a minute to pause the video, get the information, please do so. I would pause it now. I'm going to scroll up to page 170. So two things we learned was additive reasoning and multiplicative reasoning. Clearly, if you're adding, it's even included if you use subtraction, that's additive reasoning. Multiplying, we can use multiplying, and that means multiplicative reasoning. These are predictions. So now we go back to page 170, as you see right here with this pretty little scoreboard. We see Crusaders, we see Blue Jays. We notice the halftime scores are recorded and the final scores are here. The Crusaders and the Blue Jays just finished the first half of their basketball game. So the question asks you to predict their final score and please explain your reasoning. So that's what we're going to do for this first one. Our answers may be different. They can be the same. This is your own observation, your own prediction of what the scores can be. So if I predict multiplicative, then clearly I'll be multiplying. If I predict additive, then I must be adding for my scores. So Mr. Christian is thinking the scores are going to triple. Triple scores for the final score. So if they're going to triple, they started with 30. Triple means multiple. Excuse me, y'all. I had to take a sneeze. Triple means to multiply by 3. So we have to know what 30 times 3 is and 20 times 3. So 30 times 3 is 90. So I predict my final score for the Crusaders would be 90. For the Blue Jays, it would be 60 because 20 times 3 is 60. That's my prediction. That's what Mr. Christian is predicting. So what I want you to do is I'm going to draw a giant little bar right here. Triple scores for final score, which means the Crusaders will have 90. Blue Jays will have 60. I used multiplicative reasoning. So that's what Mr. Christian predicts. What I want you to do under my red line, I want you to pause the video and figure out another way to predict their final scores. You can use multiplicative or you can use additive reasoning, but it should be a different prediction, and please explain to me. I'll be looking for that in class. So I would take a minute to pause the video and then write your prediction. And what reasoning did you use? Mr. Christian will ask you about that the following day. All right, you guys got this. You're amazing. So I would take a minute to pause the video so you'll be able to work on that. Shouldn't take you too long. All right, that should be enough time for y'all to finish. We're going to resume. So we just completed page, let me click it real quick, page 170. We already completed page 171. That's why we went backwards. Now we're going to move on to page 172. That's where we're going to move on to page 172. So everybody should be on page 172. Now we're going to read up here. One of the students uses additive reasoning to make her comparison, and the other used multiplicative reasoning. So here's the formal terminology for additive reasoning that we need to use. Additive reasoning focuses on the use of addition and subtraction for comparison. So additive, let's write a little note. Additive reasoning. Mr. Christian loves acronyms. Additive reasoning, we use addition or subtraction. Either one is classified as additive reasoning. Now for multiplicative reasoning, it focuses on the use of multiplication and division. Commonly multiplication, but division technically is included, but it's commonly that. So multiplicative reasoning, we use multiplying or dividing. Remember, I love acronyms, so symbols are great. Very good. All right, so number 2 asks you which student used additive reasoning and which used multiplicative reasoning. So let's look through that real quick. So we're talking about Vicky and Benjamin. Vicky and her nephew Benjamin share the same birthday. They were both born on March 4th. So let's do some highlighting for information like you learn in English. So Vicky, I'm going to highlight right here. Today I'm 40 years old and you're 10. So Vicky must be 40 years old and Benjamin must be 10. I'm 4 times as old as you are. That's an interesting word. The word times is a big hint of what reasoning I'm using. Since I'm using the word times, that sounds like multiplicative. Benjamin says, wow, you're old. And then Vicky responds with, yeah, but in 5 years, I'll be 45 and you'll be 15. Then I will only be 3 times as old as you. Another interesting word, time. I wonder what reasoning that is. Multiplicative. Benjamin responds, I'm catching up to you. And then Vicky responds with, and 15 years after that, I'll be 60 and you'll be 30. Then I'll only be twice as old as you. So that's interesting. Let's look at that a little bit more. Let me get a different color highlighter. So they're saying 15 years after that, I'll be 60 and you'll be 30. Then I'll only be twice as old. Twice means 2 times. That also sounds like multiplicative. In enough time, I'll be older than you, Aunt Vic. Interesting. So is Vicky correct about how their ages change? Is Benjamin correct in thinking that he will eventually be older than his aunt? So I want you to take a minute to pause the video, reread through that real quick, their responses to each other, and then I'm going to write something for you. But I want you to take a minute to pause and then process it yourself. So please pause the video now. All right. So you should have had a minute to process it. So the question was, is Vicky correct about how their ages change? Well, let's look at that. Vicky first stated, I'm 40 years and you're 10. That is 4 times. 10 times 4 is 40. I agree with that statement. Let me change colors. I like green. In 5 years, I'll be 45 and you'll be 15. So you'll be 45 and then 15. That's interesting. So they said 3 times. Okay, this one said 4 times. This one said 3 times. That is true. 15 times 3 is 45. And in 15 years after that, I'll be 60 and you'll be 30. Then I'll be twice as old. That is true. 30 times 2 is 60. Interesting. So this clearly shows a multiplicative relationship. They're constantly multiplying. Do the numbers change what you're multiplying by? Absolutely. But this is definitely a multiplicative relationship. However, Vicky and Benjamin will always be 30 years apart. If you notice, their difference in ages will never change. As the years go on, that difference in multiplicative relationship will never change. For instance, from 40 to 10 is 30 years old. 30 years difference, I apologize. 40 years difference. From 45 to 15 is also a 30-year difference. From 60 to 30 is also a 30-year difference. So that will never change, but it definitely shows a multiplicative type relationship between the two. But is the multiplicative relationship ever the same? No, it is not. Actually, let me scroll that down. My brain got fried for a few seconds, y'all. You know that happens every blue moon. So we noticed in the first part, it was multiplying by 4. Let me scroll back up. I don't know why it's not showing on my screen for a minute. In the first part, it was multiplying by 4. In the second part, it was multiplying by 3. And then in the last example, it was multiplying by 2. So it is a multiplicative relationship. However, the constant that they're multiplying by will never change. So let's write that in a fancy math way. So let me write it here. The multiplicative relationship at any given time is not the same. So I wonder what that means about the additive relationship then, the difference between their ages. That's an interesting question. I'm not going to respond to that one. So what is the additive relationship between the two? I'm just curious. I want to know what your thoughts on that is. What is the additive relationship between the two ages? Let me clarify that. I'm going to ask you that question in class, and I want to hear your thoughts on that. It'll be great if you're able to write it here, but I do definitely want to hear your thoughts on that one. So very good. All right, so we officially completed page 172. So let's do a small recap. We talked about additive relationships and multiplicative relationships. Additive relationships deal with addition or subtraction. Multiplicative relationships deal with multiplying or dividing. So we haven't started ratios yet, but we will get there. So let's finish up additive and multiplicative relationships. So we completed page 172. We are now on page 173. So in page 173, we're going to start seeing the comparisons of the relationships. We're going to notice this in this chart here. So let's read the information. The table shown represents the different statements between Vicky and Benjamin. So it's talking about Vicky and Benjamin. You need to make sure that's always highlighted, circled, or whichever way, underlined. You need to understand what you're talking about. V represents Vicky's age and B represents Benjamin's age. So I'm going to read starting from the left to the right. So the verbal statement, today I'm 40 years old and you're 10. That's interesting. So Vicky is 40 like we've done before. Benjamin is 10. The equation, they wrote it as an equation. Vicky's age is equal to Benjamin's age plus 30. Interesting. So if you did that question I asked you a while ago about what's their additive relationship, we notice what's this equation representing? They're adding. So this must be an additive relationship. Now, I'm 4 times as old as you are. There's a key word again, times. Vicky's age is 40, Benjamin's is 10. 4 times Benjamin's age gives you Vicky's age. That must be multiplicative. So I want you to take a minute to pause the video and try to answer the last 4 on your own. Hopefully you see the hint there. Make sure you read the verbal statement, read the equation, and then come up with your answer. It is either additive or multiplicative. Please pause the video now. All right, so that should give you enough time to finish this on your own. So here we go. For this answer here, I notice a big hint is the addition symbol. So that's an additive relationship. If it says, but in 5 years, I'll be 45 and you'll be 15, they're essentially just adding 5 years, which is another hint. All right, for the next one, you should have got multiplicative. Mr. Christian can't spell sometimes. Y'all know me about that. I need some Starburst. I need some sugar in me. Whew. Oh, there's a good Starburst. All right, so for the next one, you should have got additive. And the final one should have been multiplicative. Hopefully y'all got the same answers as I did. No, what am I kidding? I know you did because you're bright as heck. So let's scroll a little down. So part A asks you to complete the last column by identifying each relationship as either additive or multiplicative, which we just did. At part B, at any point in this age scenario, which relationship does not change? That's interesting. So which one of these relationships have never changed? If we look at this, it's additive. It's always adding by 30. If we look at it from a multiplicative standpoint, it multiplied by 4, then it multiplied by 3, then it multiplied by 2. So notice the blue highlights consistently change and the yellow do not. Ergo, it can only be the additive. The additive relationship between the two does not change. And if you did that question I offered you on page, what was that page again? Page 172, that's where I was going at. What was the additive relationship between the ages? The additive relationship was adding 30 and it does not change. All right, great work, y'all. Bright kids. So we officially completed page 173. We were talking about additive and multiplicative relationships. We have not talked about ratios just yet. We're building toward it. So we're going to go to page 174. This should be our last page, I believe, for the day, but let's check out. I'm not going to make a lie out myself, but here we go. So now we're getting a little bit into more ratios. We're starting to dive a little bit in. So we're going to read a little bit of information here. So we're going to think about the different comparisons of two quantities. The school colors at Rearview Middle School are a shade of green and white. The art teacher, Mr. Wraith, knows that to get the correct color of green, it takes 3 parts blue paint and then 2 parts yellow paint. So it's only green and white. So that's interesting. There's some key information we've highlighted. Notice I like the colors here, the 3 blue, 2 yellow. There are different ways to think about this relationship and make comparisons. One way is to draw a picture or a model. From the model, you can make comparisons of the different quantities, blue parts to yellow parts, yellow parts to blue parts, blue parts to total parts, interesting, yellow parts to total parts. So if we notice some key differences between the highlighted yellow and highlighted purple. In the highlighted yellow, notice it's only comparing parts to parts. In the highlighted purple, it's only comparing parts to whole. Remember, parts to parts is what the 2 parts take to make a whole. So in this case, blue and yellow will make a green. So those are parts of green. Blue to total parts, which means it's taking only the part of blue, and then it takes the whole, which is the blue and the yellow. Those are 2 key words that we're going to have to pay attention to, parts to parts and parts to whole. But it's very clear which is which if you read very carefully. All right. Each comparison is called a ratio. So now we officially dived into ratios. So I wonder how multiplicative relationships and additive relationships deal with ratios. Interesting. Hopefully we get to see that, or you're able to make that comparison before I show you. A ratio is a comparison of 2 quantities that use division. Big keyword there, division. I not only highlighted, but I also boxed it. So ratios are using division. That sounds like a multiplicative type relationship to me. Interesting. The comparisons in the first column are part to part. Oh, just like we stated, because you are comparing the individual quantities. The comparisons in the second column are what we refer to as part to whole ratios, because you're comparing one of the parts to the total number of parts, just like we labeled. So you don't have to highlight these other parts since we are clearly describing these in our highlighted sections. Suppose Mr. Wraith needs 2 parts of blue and then 5 parts of yellow. Probably should change those colors, but to make a green. In fact, let's do that. I want to change that. Oh, won't let me change. It's okay. So here we go. Compare the quantities of blue and yellow paint in Mr. Rath's mixture by writing all possible ratios of each type. So we're not going to just write one, we're going to write all parts. So we're going to write part to part ratios. Well, part to part only compares part to part. So if we reread this here, it says 2 parts blue, 5 parts yellow, and that makes a green. So last time I checked, the blue and the yellow are the parts. So how do we write ratios of parts to parts? Well, we can compare the blue and then compare it to the yellow. We do use colons here to represent that information. We'll get more into that later. And we also write yellow to blue. Does it matter which one is first and which one's second? Typically, no. It just depends how you compare them. And that's sort of up to debate. Mathematical field is a whole deal. But in blue to yellow or yellow to blue is perfectly fine, as long as you state what's going on. So when we write blue to yellow, well, how many blue parts does it take? It takes 2 blue. I like B to stand for the letter for blue. And it takes 5 yellow. And I'll write 5 Y because Y will stand for yellow. So this was if I was comparing 2 parts blue, then 5 parts yellow. Could I write it differently? Absolutely. I could write 5 parts yellow and then 2 parts blue. It doesn't matter the order here because we're still going to get a green paint. But that's part to part ratios. What is the difference between part to part ratios that we wrote? The biggest difference is the order. They're just written in a different order. Written in a different order. That's the biggest difference. Now, part to whole ratios is a little bit different. In fact, I would like you to try to pause the video and try to create it yourself on a separate sheet of paper. Try to create it yourself on a separate sheet of paper. And then you're going to see what I wrote and then what I talked about. So please take a second to pause the video and try that yourself. Go. All right, so here we back. So hopefully you did that. Let's see what you got and let's compare it to mine. So part to whole ratio is what we're going to talk about next. Well, part to whole is pretty self-explanatory a little bit. Part means I need to take one part, and then the whole means I need to have the whole thing. So let's look at this very carefully. So we know 2 parts blue, 5 parts yellow, and then I get 1 green. So let's try part first. Well, there's a 2-part blue and a 5-part yellow. So I already know I can write 2 examples where I can state, hey, we can say blue to the total. Total in this case would be green. We can say, oh, yellow. I had a brain fart for a minute, y'all. Y'all know I have those every blue moon. That's why I need to eat a banana or something. Yellow, and then we can have total. So those are our ways to write it. Now let's talk about blue. How many parts of blue do we have? We have 2 parts. So I know I could write 2, and I like B for the word blue. Now total is interesting. It takes 2 blue, 5 yellow. That means the total amount of paint must be 7. You don't have to write the word total. I prefer to because it helps me not make mistakes. I'm definitely going to make y'all do it in class just to make sure you get used to it before we get rid of some of these little acronyms for blue and total and stuff. So 2 blue, and then there's 7 total because 2 plus 5 is 7. Similarly for the yellow, there are 5 parts yellow, and then there's a total of 7 again. So it wasn't that bad. Total just means you need to have the total amount of paint you're going to use. So we know the 7 really means 1 green, but we have to represent the total amount of paint that we're using. So what's the biggest difference between part to whole ratios that we wrote? The only real big difference is the different numbers for the parts. The different numbers for the parts. That's the only real big difference. So let's recap real quick, because that's pretty much concluding the lesson here for now. And we'll definitely do some more examples in class, but let's talk. So we have covered ratios, multiplicative reasoning, and additive reasoning skills. Additive reasoning means we're adding stuff or subtracting. Multiplicative means we're multiplying or dividing. Ratios incorporate a multiplicative type of property with this division. But we did notice there is some addition here when we made that total statement. So that's a little interesting, and we'll definitely talk about that more in class. So we talk about ratios, multiplicative, and additive reasoning skills. So y'all officially completed the video. Great work. I definitely want to hear some of what y'all feedback was when we get back in class. All right, amazing ones? All right, I'll see you tomorrow. Just be safe and do well, okay? All right.